Our most honorable friends, with our greatest, comfortiest, most welcome for you all. Today we have brought a VVI topic, dimension in physics, most important from all the competitive point of view. Also, it must be seen and listened quite seriously, come concentratively, as we think you all would have already been well acquainted with this topic, because it very often belongs to the various chapters in the various concerning subjects is kept for the previous classes. You all are also fully prepared to take a short skin wherever and whenever you feel it quite essential, important and necessary, without any hesitation or suffocation. The institution has no objection or restriction for it at all. As we do think you all would have already been well acquainted with this topic through the various chapters: mensuration, height and distance, weights and measures, time and distance, time and work, etc. in maths, science or other subjects, in form of used such measuring terms such as length, breadth, height, depth, width, thickness, diameter, circumference, radius, density, frequency, area, volume, surface area, mass, density, velocity, time, distance, etc. All these measuring quantities or the terms are the simplest, easiest and most understandable form of dimension, most popularly used in maths or simple science. In internationally standard science, highly standard science or higher classic science, the dimension has same meaning, same concept, same sense, but it has a best specified cum modified standard scientific form of all these simplest cum easiest form of the simplest measuring quantities. It is expressed as in a best modified standard scientific form formed by the combination of all the correlated corresponding measuring fundamental quantities of a given physical quantities. in the form of such as
बस
in all these expressed form enclosing big bracket, the raised power or indices are mainly chiefly known as dimension, most popularly used in physics and chemistry. To show the correlation and codependency conception of all the correlated corresponding physical measuring fundamental quantities of a given physical quantities. In these expressed form, M, L, T, I, K, C, indicates the symbol of main fundamental quantities or basic quantities. All the other dimensions are always expressed in these terms of the main fundamental or basic quantity LMT IKC. Thus, it is quite clear that dimension is only, mainly, chiefly, simply the raised power or indices of all the correlated corresponding measuring fundamental quantities now. In best details also we define it, we define the dimension as its best introduction, and then we will discuss, interpret or explain its deep details also. corresponding raised indices or powers to which all the inherent correlated corresponding measuring fundamental quantities of a given physical quantity are raised to best express their correlation dependency conception or its nearest derivation and representation quite easily, perfectly comfortably are called dimension. As we have already expressed and explained, all these terms involved in this definition. The term raised power or indices is quite clear already before, because you all already know it is the same power or indices as used in mathematics or science. For further details, all the inherent, correlated, corresponding physical measuring fundamental quantities are mainly six or seven fundamental quantities is considered as mole. The amount of chemical substance, it is mainly used in chemistry. Where atomic or subatomic mass is mainly used. In physics, mass of matter, mass of bulky substance is mainly used, while in chemistry, mass of atoms, molecules, subatoms are mainly used. Bulky mass is rare in chemistry. Bulky mass is mainly used in physics. All these six are main fundamental quantities in which dimensions are always expressed. As for example, dimension of velocity is L(t) minus 1 or inverse 1, also ever enclosed in big bracket or a square bracket. Or also in other form, both forms of the dimension are equivalent. Both forms are the dimension of the velocity. In first form, m is absent, there is no m, and in second form, m is also expressed, but in pseudo form, because m has dimension 0, it means mathematically 1. that is a number. It means mass is absent, is nil in the velocity or in the dimension of the velocity. Also, it means velocity does not depend on mass. It only depends length and time. Thus, dimension also indicates the codependency and correlation of all the fundamental quantities involved in a particular quantity. Also, the dimension of force is expressed as ml t minus 2 or inverse 2. In this dimension, all the three fundamental quantities m, l, t, mass, length and time, are involved. It means force depend all these three quantities, mass, length and time. And also force does not depend the other fundamental quantities such as I, K, C. That is electric current, thermodynamic temperature, luminous intensity, in light. On these three fundamental quantities, force also does not depend. Similarly, the dimension of momentum is ml t minus 1 or inverse 1. It is the dimension of momentum. And so on. You also can write the dimensions of various quantities. I also express how to write the dimension of a given quantity. Mainly to write the dimension of a given physical quantity, firstly we should know its perfect definition or quantitative conceptions, quantitative concerning quantitative conception obtained through any related law, rule, principle, theory, postulate, etc. As for example, to write the dimension of velocity, we think about the perfect definition or its concerning quantitative conception. As we do know, velocity is considered as VCR, DCR, and acceleration is considered as VCR. It means here velocity means displacement change rate. Acceleration means velocity change rate. Force, MCR, force is also considered as momentum change rate, and force also is considered as the product of mass and acceleration produced. Now we explains how to write the dimension of velocity. Firstly, to write the dimension of velocity, we have discussed, we have considered, we have defined as DCR, displacement change rate. That can be written as mathematically velocity is equal to